Now let's actually explain artificial neural networks with very maybe interesting examples. And during we say explaining these examples, somehow I try to explain different concepts and techniques that we have in say artificial neural network. Think of a neural network like a cookie factory. Okay, we have first input station or ingredients in. Okay, you dumps in bowls of say flour, sugar, eggs, and chocolate chips, the raw data. Okay, in machine learning terms, this is your input layer receiving feature values. Okay, the next is mixing department, first hidden layer. Okay, workers or neurons combine ingredient in set proportions that we called it weights in machine learning. Each worker measures, for example, 2 cup flour, multiple 0.5, or 3x, a multiple 0.8, then say sums everything up. Okay, and then we have ON department, that is play roles like activation function in machine learning. The mixed butter goes into oven. Okay, that only let dough that's above a certain temperature, or that means threshold, actually bake. Okay, in neural networks, that's like a ReLU or sigmoid function deciding which signal pass through. No. And we have the creating department. Okay, in this factory, we have a department. It's called the creating department, or subsequent hidden layers. Okay, now the cookies come out plain. Other teams add sprinkles, shape them into hearts or stars, or pipe on, say, frosting. More layers of transformation. Each layer learns ever more refined patterns, from baked cookie to, say, chocolate chip cookie to, for example, cookie with blue icing. Next, we have quality control and packaging, or output layer. The final inspectors sort cookies into, say, boxes labeled classic, sugar, or double chip. That's your network's prediction. Okay, it's classify or generate a final result. And we have recipe tuning or training. Okay, after tasting, you might tell the first mixer, okay, use 10% more sugar, and tell the decorator add fewer sprinkles. Okay, these feedbacks travel back through the line that we called it back propagation in machine learning, adjusting each station recipe. Say that we called it weight, and so future batches match the target flavor or somehow minimize loss. You know, and we have avoiding over decorating or regularization. If you let the decorator go wild, every cookie ends up, or say, loaded with say sprinkles and taste inconsistent, and like the concepts of overfitting that we have in machine learning. By occasionally skipping the decorator exactly play role of say dropout techniques in machine learning, or limiting how much say frosting they can use weight penalty. For example, and you keep the factory flexible, and the cookies, we say, reliably, um, say, tasty on any new order.